Welcome back again to this edition of the tutorial. We are still continuing the subject of simultaneous equation. Simultaneous equations, and we have already considered elimination method. We have also considered substitution approach as well, and I think we have also considered the y equals to y approach as well. And in this session, we are continuing the elimination. No, we are continuing the next particular question. We will devote our time by using the substitution approach and the y equal to y approach, and then we'll consider the approach of matrices. Yeah, then let's take the question. The question said that solve the equations. Here, two equations are given, and it is 7x plus 9y equal 3. And the second one says that it is 5x plus 7y equal 1. I'll call this one equation 2. And I call this one equation 1. But relatively, you can see that the two equations, 1 and 2, they are no different from a1 x plus b1 y equals c1. And this one is a2 x plus b2 y equals c2. This is it. In the first place, we are considering the substitution approach. Why? Because if you watch closely to this particular equation, you can see that to do elimination approach, it is possible, but there are some few algebraic manipulations you have to consider, because 7 and 7 has no common relationship whatsoever, and 9 and y they both have no relationship whatsoever. So elimination approach is quite possible, but it will require a little bit of algebraic demand. This is it. So without wasting time, there is also you can use substitution to bank it down. Now, see, if we are going to use the substitution approach, then look here. Let me pick up, I can pick either equation 1 or equation 2, whichever is possible. But it is expedient, maybe to take the first equation. Let's say the first equation solution. I'll begin by saying solution. As we've negotiated to use to start with equation 1, we say that equation 1, which is 7x plus 9y equals 3, can be rearranged to be equal to x equal 3 minus 9y over 7. In that case, I'll call this one, as we already have equation 1 and 2, I'll call this one equation 3. Now, having got equation 3, you cannot put the equation 3 back into equation 1 because it is still the same equation, having been rearranged in another format, However, having got the x, you can put it in equation 2. So, putting equation 3 into equation 2 will yield 5, that's equation 2, 5, x. Instead of the x, what is x? X is this one. You put this one as 5, x is, instead of x, you put 3 minus 9y over 7. Then you have the plus over there, plus 7y equal 1. Having got that, you can, algebraically, you can multiply through by this denominator. In order to do away with this denominator, you can multiply both sides by 7. In that case, we will have, the reason why I'm moving very fast is that, at this time, your algebraic proficiency is quite good, so you can follow what I'm doing. So it becomes 3 minus 9y. We are multiplying both sides by this denominator, so it becomes plus 7y being multiplied to the 7 equal 1 being multiplied to the 7. Then we have here 15. 5 times 3 is 15. Then we have minus 5 times minus 9y. We have 5 times minus 9y minus 9y plus 7 times 7y times 7, we have 49y equal 1 times 7 is 7. Good. There's still a space over there. So you still have 15. You still have 15. 5 times 9 minus 5 times 9 is minus 45. Plus 49 minus 45y plus 49y equals 7. Now, we'll move on to the next section of the board. So, here, we continue as we are going to collect the like terms together in the year. So, we will leave the y terms at the left hand side, whichever way. So we have 49y, which is this one, 49y minus 45y then this 15 is going to cross the boundary line, which is equal. Being positive here, when it crosses to this side, it is going to be negative. So already at the right hand side, we have 7 there, and the 15 is traveling to the right hand side. Being positive at the left hand side, once it crosses over the frontier, it becomes negative. So minus 15 minus 15. So now you can see that we have 49y minus 45y, which will give us 4y. Let's say 4y, then equal 7 minus 15 will give us minus 8. Then we make the y the subject by transferring the 4 to this side. So it becomes y equal minus 8 over 4, which implies is y equal minus 2, which is very important. Now, we can also find the x value. As we know the y value, we can find the x value by putting the y inside this any of this equation. You can do it in equation 1, you can do it in equation 2, and you can rearrange it to have the x value. But remember, you've done a wonderful job before, and that was equation 3. In equation 3, you already have x as a subject, and you have y at the right hand side. You can put this y there, and you can straight away find the x value without wasting time. In that case, you have x equal 3. Okay, I think I have to make it more clear. Put in y equal minus 2 into equation 3. You have x equal 3 minus 9y. What is y? Y is minus 2 over there, then over 7. So you have here 3 minus 9 multiplied to minus 2 will give us 3 plus 18 over 7, which is equal to 21 over 7. 21 over 7. Therefore, x equal 3. So you can see that you have already solved the simultaneous equation. And you have y equal to minus 2 and s equals to 3. Therefore, hence, the solution of the given equations is you have s equals to 3 and y equals to minus 2. This is the solution of the equation. As we've already said, that the solution of the equation is the point where the two lines, these two lines, intersect. So these two lines, they do intersect at where x equals to 3 and y equals to minus 2. Then you are done with that equation. You solved it. Yes, take your time to copy it, and then we'll come back again. Yeah, as I'm standing this side, I'm trying to provide a proper view for you to see everything so that you can pause the video and then you can copy everything as clear as you can see. Yeah. Now we are continuing again. The approach that we used was elimination approach, but at this time we will use quite different approach, which is I call it the y equal to y approach. What is the y equal to y approach? I'll show you. Take your time. Let's pick up the equation 1 first as a point of preference. 7x plus 9y equals 3. We are trying to make the y the subject because we are using the y equal to y approach. So in that case, we have systematically, we have now 1 equals to 3 minus 7x plus 3, because 7 has traveled from this side to this side, while 3 remain there. So then the next one we have y equal minus 7 over 9x plus 3 over 9. Yeah, this is equation of a line. I take it this form and I call it equation alpha. But remember, the same equation alpha is also not different from y equal minus 7 over 9x plus 3 3 over 9 is equals to 1/3, which is no different from y equal mx plus c, which indicates that the gradient of this line is m, which is minus 7 over 9, which indicates that that gradient is a line with negative gradient. A line with negative gradient is expected to be something like this. It goes this way or that way, whichever way. So either this or this. That's a line with negative gradient. Either that or that. It depends. It depends upon this one, for instance, as you see. The y-axis intercept is not negative. The y-axis intercept is c. So presumably, the graph of this line will be something just like this. Yeah, here is y and here is x. Good. But I think that we can use the opportunity to find the y-axis, the x-axis intercept as well. As we know that the y-axis intercept is the c, which is 3 over 9, or which is 1 over 3. So here is y-axis intercept, which is 1 over 3. But what about the x-axis intercept? We say that on the x-axis, y equal 0. When y equal to 0, let's choose this simple equation, this one. When y equals to 0, then this portion of the equation, as y is equals to 0, this y will be equal to 0. So we have 7x plus 9 multiplied to 0 will give us 0, goes to 3, which indicates that x equal to 3 over 7. So this point is 3 over 7, while this is the origin. So this equation, as you see there, this one or this one or this one, this should be the line. So I will say that this line is 7x plus 9y equal 3. This is this line. Now, let's see what we can do with the next one. I think I may have to, well, let's use this section to continue. From this equation, we'll do the same thing as we did there. So, from equation 2, we have, we are trying to make y the subject, so it becomes 7y equal minus 5x plus 1, which implies this y equal minus 5 over 7x plus 1 over 7, which is also no different from y equal minus, yeah, it's still the same, yeah, which is also the same as equation of a line, which is mx plus c. Comparing both equations, you can see that the gradient m is equals to minus 5 over 7, which indicates that that gradient is also a negative gradient. And the y-axis intercept is also 1 over 7. So, I would say that on the y-axis, we see that the line will cross the y-axis at 1 over 7. What about the x-axis? On the x-axis, y equal to 0. Then, put y equal to 0 in this equation. So you can find out that this is 0, becomes 0 equals to minus 5x plus 1. 5x equal 1, which implies is x equal 1 over 5. This is the x-axis intercept, but remember, the line has a negative gradient, so it will be like something like this. This is the y-axis, and this is the x-axis. So the curve crosses the x-axis at 1/7 and crosses the y-axis at 1/5. Presumably it should be something like this. So this is the origin. So this should be the line of 5x plus 7y equal 1. Very good. So now, all these things, honestly, they were we extended ourselves because because maybe we want to draw the graph or something like that. But as soon as we hit this point, I'll call this one equation beta. As soon as we hit equation alpha and equation beta, we were almost done. But we just stretched ourselves to and extended the work by going to find the y-axis and the x-axis intercept, which though was not required in the question. But this being a private tuition, I think that everything we have to give the best. So that's the reason why we are doing a detailed work. This is it. So all what I'm trying to say is that the time when we hit alpha, there was no need to go down all this way, with all these graphs. But we extended it just to extend your knowledge on things like this. Okay, so very soon we are going to use the equation alpha and beta. But in the meantime, if you are going to, if you think that you are going to sketch both graphs on the same axis, it was something, unless we do it on scale, we cannot find it exactly. But approximately, the graph will look like this one, and then this one, and then this one. Where this one, where this is the 7x, the line 7x plus 9y equals 3, and this one is the 5x plus 7y equal 1. This is the x-axis, and this is the y-axis. And this point of intersection is where we have the solution. The solution, y was equal to, I think we still haven't found the solution. We'll find it. So this is the solution that we are looking for. Though we knew from the previous substitution approach that the x was equal to 3 and y was equal to -2. This is the point of intersection. But now we still haven't found the point of intersection or the solution of the simultaneous equation. Having got these ones down, now let's see how we can find the solution of the simultaneous equation. This is it. So in finding the solution of the simultaneous equation, we are going to use alpha and beta. Take your time, copy this one, and then we'll take it from there. Take your time. Come back. This were the equation that we derived earlier. This one is not different from, this equation is not different from y equal -7x plus 3 over 9. And this one is also not different from y equal -5x plus 1 over 7. Okay. Still equation alpha, and this still equation beta. Alpha, and this still equation beta. Now, at the point where the two lines intersect, their y values have to be the same, or their x values have to be the same at the point of intersection. In that case, it would indicate that y will be equal to y as y equals to y as the two lines intersect. In which case we will have y is minus 7x plus 3 over 9 equal minus 5x plus 1 over 7. We are going to cross multiply. This one will be shifted here to multiply this expression, and this 9 will be shifted to the right hand side to be multiplied to the upper expression. So you have minus, you have 7 being multiplied to minus 7x plus 3 equal 9 being multiplied to minus 5x plus 1. So you have here minus 49x plus this is 7 multiplied to minus 7x is minus 49x. 7 multiplied to 3 will be plus 21x, which is 21, sorry, plus 21, sorry, plus 21. 7 multiplied to 3 will be 21. Then have equal. Then 9 multiplied to minus 5x, you have a minus 45x. Minus 45x. 9 multiplied to 1, you have plus 9. So we are trying to group the like terms together. So we will push, it becomes 21. 21 stays there, and we bring the 9 over there. Minus 9 equal 49 is positive here. It is crossing the frontier. So it becomes it is negative here. So it is crossing the frontier. It will become positive. So it will be 49x minus 45x. So 21 minus 9 will be 12. Be 12 equal to 49x minus 45x will be 4x, which implies is x equal 12 over 4, which indicates at the point of intersection s equals to 3, exactly the same as we had in the previous approach. Now, what about y? We can find the y value either by using any of these equations. We can find the y values, whichever we choose, any one. Maybe let's try to choose this one. Y equal, using this one, using equation beta. I would rather continue here. Using equation beta, we have y equal minus 5, x is 3, plus 1 over 7. So we have y equal minus 15 plus 1 over 7. Y equal minus 14 over 7. Y equal minus 2. So you can see that the solution of the simultaneous equation is s equals to 3 and y is equals to 2. Therefore, the solution is x equal to 3 y equal minus 2. Exactly what we had in the previous. Is it clear on the board? Yeah. That's the solution. Now take your time to copy everything, and then we'll continue. Take your time. So far we have discovered the approach of elimination and the approach of substitution. And at this time, I want to introduce to the analysis of matrices, how we can use matrices to solve some simultaneous equations. Honestly, using matrices to find solution of equations, I mean, they are very common in electrical engineering practicing. They are also common, especially in mechanics statics and mechanics dynamics. If you are going to study civil engineering, I'm talking about proper civil engineering, structural engineering. If you are going to study mechanical engineering, there are some areas that you use simultaneous equation depending upon the question. In some cases, it could be 4 equations with 4 unknowns. It could be 3 equations with 3 unknowns. It could be, sometimes being 4 equations with 4 unknowns. You use something called the equation of constraints, and then it is how you may do it. And for instance, also in electrical engineering analysis, in electrical circuits, you can also use matrices. Whereby to find some variables in some equations, and they are simultaneous equations anyway, so you can use matrices to find them. And in some areas like linear control systems, which is also another branch of the electrical engineering. In German, we call it Mess- und Regelungstechnik. It requires a lot of metric algebra. This is it. So, precisely solving number of equations with some unknowns, you can use matrices. Solving some simultaneous equations, with some unknowns, you can use matrices. Now, let me introduce you to 2x2 matrices. The 2x2 matrices is so far what we've been considering. For instance, if we have an equation like A, 1x plus B1 y equal C1, I'll call it equation 1, as previously we saw. Likewise, if you have the second equation being A2x plus B2y equals C2, equation 2. Now, this equation can be expressed in matrix form. So matrix form, I'll call it matrix M. Therefore, the matrix M will be equal to A1, B1, A2, B2. This is matrix form. I call this one matrix M. Therefore, I'll call this equation matrix M. Let's do it neatly. This is a private tuition, so everything you have to know. At some point you can have something to shout about it. The tuition that you have, it is top-notch tuition, first class. So everything that we know about, we have to give it to you. For instance, this one I'll call it equation, let me call it equation 3 at this time. Equation 3 is the matrix M. And then there's something that we do in matrices. We call it the determinant. Now, if you have a matrix like this and you want to find the determinant of the matrix M, the determinant, I will say the determinant of the matrix M is given by M is denoted like this. This is the determinant. So this matrix M, you want to find the determinant of this matrix M. It is no different from A1 multiplied to B2 minus B1 multiplied to A2. This is called the determinant. A1 multiplied to B2 minus B1 multiplied to A2 is called the determinant of M. So, the determinant of the matrix M is this one. So, I'll call this one equation 4. I'll call this one equation 4. Call this one equation 4. Good. Now, this is the determinant of M. Very good. And I call it equation. Equation 4. Now, let me do it properly. I call it equation 4. There's another element that I also want you to know. I call this one point 1. I call this one point 2. And there's another point that I want you to know. It's called the adjutant of the matrix M. Adjutant of the matrix M. I'll denote it like adjutant of M. Adjutant of M, I'll write it down and I will explain it to you, is equal to B1 A1 and this time I'm going to swap the position of A1 and I'm going to swap the position of A1 and B2. So you can see that the B2 comes here and then the A1 comes here. But as soon as I do that, I will negate B1 and negate A1. Now, let me explain what I've done. To find the adjutant of a matrix M, you swap this. This is the matrix M. To find the adjutant of that matrix M, you swap the position A1 and B2. You swap it. As soon as you swap it, immediately you negate B1 and A2, as I've done it here. So this one is called the adjutant of the matrix M. And I'll call it equation 5. Now, what I want is, I want the fourth point is called the matrix inverse. The matrix inverse, I think that before I do the matrix inverse, we have to go back to equation 1 and 2. Good. In that case, then let me borrow this section. And watch here. From equation 1 and 2, as you see, we can write equation 1 and 2 like this way. Maybe, let me start from here. From the equations 1 and 2 being of the form a1x plus b1y equals c1, and the other one being a2x plus b2y equals c2. Mathematically, in matrices, these two equations is not different from x. I'll do it this way. It's not different from x, or I'll say it. These two equations can be expressed as x, y, a1, b1, a2, b2, equal, oh, sorry. Multiply to C1, C2, this equation, as you see there, it is the same like this equation. So probably it will be more reasonable to do it this way. This equation is not different from x, y multiply to, is there a space there? And is the color popping up? The color is not popping up. What do I do? What do I do? We'll manage it. This one is equal to A1, B1, A2, B2, equal C. No, the color is not popping there. Can I use the color is not popping there. What do I do? No, I have to write it here because you can't see it properly. If I see on my screen, I can see that this area, the lighting system is very dull. So I wouldn't risk it. This equation is the same as x, y, multiply to A1, B1, A2, B2, equal C2, C1. The same equation. So if you watch this equation carefully, you can see that it is something equal to, identical to big X, which is this one. And then multiply to this one we know it to be equal to matrix M. Is that correct? Good. Then let's equal there. We know we will make it big C. So this equation, as you see there, is the same as big S, where the big S is this one, and the M is the matrix, and the big C is this one. Now, I repeat again. This is very, very important, honestly. I believe in the second semester in the university, if you are doing engineering, I mean mechanical engineering or civil engineering, you'll be introduced to this. But the thing, quite unfortunate, in the universities, I mean, the professors move so fast, and sometimes some of these works, the professors, I mean, they don't take this work and they give it to teaching assistants. And teaching assistants, sometimes they come, I mean, having their notes in their hands, I mean, writing everything from the notes, I mean, not from their heads. And I mean, and if they are not motivated, I mean, in some cases, and I mean, they may not have enough time to explain it into details, as I'm telling you, and as I'm explaining it to you. And even the professors, I mean, they go so fast, I mean, and God help you if you have an arrogant professor, I mean, who goes so fast, and I mean, he doesn't care. That's it. So all these we are doing, I mean, you by means in the second semester in the uni, if you are studying mechanical engineering or civil engineering, I mean, in the second semester, they will introduce you to that. So now, you see that yeah, this equation, as you see there, maybe I have to write it more beautiful for you to see. As I said, this one, I will denote this one by big X, multiply to the matrix M equal C. Now, what you are going to do is that, watch this equation carefully. I will try to make the X the subject. If I make the S the subject, you can see that I'll have X equal, I mean, there's a more professional way to do what I'm trying to do, but I'm making it more simpler for you. You are bringing the M to this side. It should be something like this, reciprocating form, and then it will be multiplied to C. This is the equation that I need. I need this equation. And in that case, we are going to formulate it back to, what is X? X is this one. So you have X, Y. Good. Then you have M inverse. What is C? C is C1, C2. This equation is what I need. This equation is what I need. Now, This is very, very vital equation. Now, let me call this one equation 6. Now, maybe at this time, I will use this portion as well. What is M inverse? M inverse is the inverse of the matrix M. And by definition, the inverse of the matrix M is given by definition, matrix M is given by 1 over determinant of A times the adjoint of the matrix M. Can you see it on the board? No, you can see bit. Maybe, let me see my screen. Let me try different color. Yeah, I will try this color. I will see. By trying this color, possibly that color will be helpful. Then in that case, I will wipe this one off and use different color that can pop out, even though the lighting system at the right hand side is not all that great. So matrix inverse of the matrix M by definition is equals to 1 over determinant of M times the adjoint of M. Can you see there? Oh, it is far worse. It is far worse. So what do I do? What do I do? Can we possibly borrow that section? If we can borrow that section, then I'll call this one oh, no way. Still no way. Okay. The only alternative that we have is copy everything. I wipe this section, and then I will continue from this side. So copy everything as you see on the board. As I'm standing on this side, for you to have the clear view of everything, and then I'll wipe it off, and then we'll take it from there. Take your time. Now we are continuing. By definition, the matrix M, the inverse matrix, the inverse of M of the matrix M is given by 1 over determinant of M times the adjoint times the adjoint of M. Good. 1 over the determinant times the adjoint of M. This M inverse that stands there, this is the definition. So I'll call this one also equation 7. Now, from equation 7. The inverse of m is equals to 1 over the determinant. What is the determinant? The determinant is this one. This. Sometimes you will find it to be like, this is the determinant. 1 over the determinant is A1 multiplied to B2 minus B1 multiplied to A2. Then we have 1 over the determinant times the adjoint of m. What is the adjoint of m? The adjoint of m is this one. Which is B2 minus B1 minus A2 A1. This is the inverse of M. Inverse matrix, 2 by 2 matrix. Good. Then we have, this one is equation 8, VII. But remember, in one of the equations, we found out that x over y was m inverse being multiplied to C1. Yeah, this is it. This is that equation. So we don't need, I'll say that this is that equation because we want to save a space. You say that, put equation 8 back into equation 7, back into equation 6. Put in equation 8 back into equation 5. Equation 6 rather, sorry. We'll have x, y equal inverse of m. What is inverse of m? This is it. 1 over A1 multiplied to B2 minus B1 multiplied to A2 B2 minus A2 minus B1 A1. Very good. This is very, very celebrating results. I'll call this one equation 5. Very good. Then we will need this space to continue. Take your time, copy everything as I'm standing here for you to have the clear board. Copy everything and then I will wipe up this session and then we'll pick out from there. Take your time. I believe equation 5 is still not completed. Why? Because we forgot. we forgot the C's over there. So, pardon me for that. We have here C1 and C2. Good. Take your time, copy everything, and then we'll come back again. Yeah. Now, let's continue again. We left off with equation 5. At that time, it was at this side. And now we have wiped off the board, and then we have brought the same equation y to this side so that we can continue. So, this equation can be also expressed as y, x, y. Then, is equal, you have here b2, which is this one, minus b1 now we have to write the determinant before. But before we do that, we are going to multiply this one to this one. To do that, it is matrix multiplication. We'll do it this way: b2 minus b1 before that I have to do the determinant before. 1 over the determinant, which is a1 b2 b1 a2 b2 minus, then we multiply this section to this section. It becomes b2, and this is the big thing, becomes b2 minus b1 c1 c2 and the next one is minus a2 a1 c1 c2 which is not different from 1 over a1 b2 minus b1 a2 B2 times C1 minus B1, B2 times C1 plus minus B1 times C2. So it becomes B2 times C1 plus minus B1, B2 times C1 plus minus B1 times C2. Then we have here minus A2 times C1 plus A1 times C2. Here is x, y dou. So we continue. We say that x and y equal B2 times C1 minus B1 C2 all over A1 B2 minus B1 A2. And the next one is minus A2 times C1 plus A1 times C2. Yeah. Uh-oh, you can see it. You can see it. So what do I do? You can see it. Oh, no. All over. Let me see whether you can see it. All over A1 B2 minus B1 A2. I think you can see it. Yeah, you can see it. Yeah. Now, let me take off this session. So take your time. Let me stand here for you to have ample of time to pause the video to have clear board. And then you can copy everything as you see on the board. And later on, I'll wipe this session off and we'll continue from there. We are almost done. Okay, now we are continuing again. So, I mean, we can still express this form as x equal B2 C1 minus B1 C2 all over A1 B2 minus B1 A2. and y is equal to minus a2 c1 plus a1 c2 over a1 b2 minus b1 a2. I'll call this one equation micro, and I'll call this one equation sigma. Both equation micro and sigma are the solution of the simultaneous equation over there. So this simultaneous equation, as you see here, a1x plus b1y equals c1, which is equation 1. And a2, the first one is a1x plus b1y equal c1. And the second equation is a2x plus b2y equals c2. The solution of this simultaneous equation is this one. So, whichever value you find here in a simultaneous equation A, you find A1 here, then you put it there. I mean, this is what we call it as the Cramer's rule. Honestly, you can use this equation once you can memorize it. Any simultaneous equation, anyone, especially the one that you may find it very strange, if you can memorize this one, which you should be able to, I mean, you just insert everything inside and you bank everything down, you pin everything down, and then so straightforward. You have the values of y and s of that given simultaneous equation. Because of the propensity of the time, we have almost hit an hour and 20 minutes, which is, I mean, it's enough. I would have, I would like that. I mean, it was my wish that we could take an example, but because since the time is being fast spent, I don't think that we are able to do it now. But in the next lesson, we take a typical example of simultaneous equation, and then we'll use the matrices form. I mean, straight away, and we can do that one. So far, this was introduction to the matrix approach, whereby you can use matrices to solve the solution of two equations in two variables, like the one that we are treating. Now, until then, thank you for your time and for your participation as well. And may the Almighty God continue to bless you with wisdom, knowledge, and understanding. Wherever you be, may you stand out among your peers. And everything that you've learned, I mean, may the Lord Almighty God help you, I mean, to remember everything and to have everything on your fingertips. Until then, God bless you. Have a wonderful and amazing time. God bless you once again.